discrete event model that's found in Learn for your course in this section. Here we have the SLAM project file. It's a zip folder. You can unzip it and copy the resulting folder into the projects folder. Once you do that, you'll be able to open it with Awesome. This is also an importable SLAM file zip. These are the individual files that you'll need to run both the network version as well as the discrete event version. Once you load it into Awesome, you'll find a project called BankTel, and this has actually 3 scenarios in it. The base case is the network version, the discrete event version, and then also the discrete event version using the priority statement to create the wait file instead of the statement in INTLC. So we'll discuss both of those later in the lecture. Meanwhile, here's what the network looks like. Standard just single server queuing system. You can easily model this using the network approach. You're all familiar, or should be by now, with this representation. So it creates entities, marks their arrival time, stores items waiting for service in a queue. Here's the service activity, have collect node statistics and departure. Okay. Control model for this is pretty simple, has just the 5 basic control model statements that you see in most models. We have one attribute set by the limit statement, and we're going to run it for a total of 480 time units. Now let's take a look at the next scenario, which is the discrete event model. And this is shown here. The control statement for the discrete event model is pretty much the same. It only has 4 statements. There's no network statement, of course, since you don't have a network in this model, so nothing to read. You don't need one. So let's take a look at the user inserts, which is the bank teller problem. If you open up your project folder, you'll find some C files, C source files located there. And these files are designed to contain any of the C programming models that you have. So if we open up projects and BankTel, sort by types, you'll see 3 C files. Okay, this one is kind of a dummy file used to illustrate. You can use this as a template. This is the basic bank teller problem, and this is the bank teller problem using the priority statement instead of the function call in subroutine INTLC. So these are all available in the project folder. You can compile them using any compiler you want to evaluate them. Once you've finished, you can open up user inserts, and you'll see a listing of all available user inserts. These are all available C code files that are in your project folder. Notice we've selected BTEL for the bank teller example. Okay, now to explore this file, we double click it, and you'll get a basic text editor. This is fine to use for creating your models or editing. You can also use advanced C compiler. So let's go through this, and we'll look at the different aspects. First of all, we need a #include statement for the vslam.h file. This is the way you specify it. If you've installed Awesome on your computer, it should be in the C drive under Awesome and Library. You can take a look at vslam.h, but please don't change it. Your model will definitely not run if you make any modifications to it. It's also available on the remote desktop application, and you use this same include statement to run it. Next statement is the event codes for all the events in the model. Here we have a #define statement. As you know, #define basically works just like a text editor. It'll take all occurrences of the string arrival and replace them with the string 1. Okay, so it's a way of documenting your code using events that are meaningful, like the arrival event for this problem and the end of service event, but then later replaces it in a pass of the compiler with a number code, 1 for arrival, 2 for end of service. Other equivalences, we want to set the server busy or idle, so we'll pound define busy to be 1 and pound define idle to be 2, or 0 rather, sorry. We also have a global variable. A global variable are all the variables that you want to have accessible from any of the functions that you write in the discrete event portion. So we'll have one global variable in this model called status. This is the status of the server, and we want it to continue to exist even after we return from another function. Here's a function, intlc. It has a variable declaration here at the top, declaring a new variable PENew of type pointer to an entity. This variable will disappear after we return from the function, and that's not what we want for status, since we could change the status of the server either through a customer arrival or an end of serve event. All the functions that you write that don't exist in the awesome library, you have to put in a prototype of all of these, and it's just something like this statement. It has void for the type, the name of the function. This will be our actual function for arrival, and any arguments. And these two events have 2 arguments, or 1 argument each, two events, which are entity pointers, pointers to the entity information that is about to execute the event. Okay, so the first function you have to write is called intlc. There's a dummy intlc in the SLAM support library, and what you're doing is basically replacing that dummy function that does nothing but return with your own function that you write yourself. You don't have to put it in the prototype since it already exists in the library, just in dummy form. So this you can replace. This is a function that's called at the beginning of each run. It has 1 argument, which is the run number. And for our implementation, we're going to use an entity pointer because we're going to create the initial entities that arrive to the system. Okay, and we'll do it only on the first run. We'll do file definition and statistics definition. After that, on each run we'll schedule. So if in an IU run is 1, we'll only do the items between these 2 braces. So we set the status to idle of the server. We define a new file. This is a function you can call to define a new file. You can also do this with the priority statement, and we'll show you how to do that shortly. We can also collect statistics on time in the system. This function is just like the collect node, except you have to define that this type of statistic exists. So you do it here in the intlc function. So we need on run 1, where you need to set the server to idle, set up a file for customers to wait, and set up statistics to collect time in the system. After that, we hit the brace that's the end of the if statement. So we always will do this function, which is to schedule the first arrival. So PENew is a local variable that's a pointer to an entity. And we call this function su_int_new to create a new entity. This is functions much like the create node, except it only involves the creation of the entity, not any subsequent entities. So we call this with the different attribute values. The first one is the E-type value. The next 3 are ATRIB, LTRIB, and STRIB. And we can give them this special reserved SLAM word called null if we want to set them all to 0 or blanks. So that's how you'd like to set up it returns an entity pointer, and that is stored in PENew. Then we call schedule to schedule an event. We want to schedule an arrival event. This is the event code. It gets replaced by 1 in the compiler. but we can just put in the string arrival. PE new is the pointer to the entity. That's the second argument for schedule. And the third argument for schedule is the time between now and when the event is to occur. So we want it to occur at the beginning of the simulation, so we just put in 0. Now we return from the function and set true, indicating that it returned successfully. If you set return and you send it an argument of false, then the simulation will terminate. Okay, we'll resume this in the second lecture.